I subscribed.
You subscribed, Ivy? What's your screen name? Just Ivy? Okay, I thought maybe a color in there or something. Okay, Ivy. Can't find me. That's right. I put the link in the notes for you, so that would make it easy. Okay? All right. Anyway, so today what we're going to look at is piecewise functions and their graphs. We're going to do two things. I'm going to give you a piecewise function. We're going to figure out what the graph looks like. Okay? And then I'm going to give you the graph of a piecewise function, and we'll figure out what the equation looks like. We'll do that. And that sets you up nicely for your homework problems tonight that you want to practice. Okay? All right, I'm sorry about the way this looks. So let me just make this a little darker. This function reads f of x equals 1 for the domain -2 inclusive to 0 non-inclusive, x squared for 0 inclusive to 2 non-inclusive, and then x for 2 inclusive to 4 inclusive. All right. Okay then. Okay. So what we want to do is we're going to create an axis. And my advice is for trying to graph these things is just look at one domain at a time. Okay, so just pick one of the domains at a time. I'm going to start with this one. We'll do this one. I'm going to circle it in green. I'll create that part of the graph in green down here. Okay. So what x values are we concerned with for this first part of the function? What x values am I worried about? Yeah, -2 to 0. -2 is included, but 0 is not. So I'm going to mark off, here's -2, -1, there's 0. And according to this function, the y value is always 1 whenever x is between -2 and 0. It doesn't change at all. It doesn't depend on what x is. Y is always 1. Bless you. So what you do is you go up to 1, and above -2, we're going to put a solid dot because it's inclusive, because you've got that hard bracket there. And we're going to move across at y equals 1. We're not going to change it all until we get to 0. And will that have a hollow dot or a solid dot? It's going to have a hollow dot. And that's because when we actually get to x equals 0, we are no longer using the function y equals 1. Okay? Alrighty then. Now we'll go to the next section, the next piece of this piecewise function. Here it is. Okay? So, we're going to be focusing on this part of the x-axis from 0, 1, and 2. And you kind of know what a parabola looks like. You expect some kind of curved parabolic shape. My advice in this situation is plug in at least these endpoints, plug in the 0, plug in the 2, see what they look like, and maybe pick a number in between also. Okay? So let's say I plug in 0. 0 squared would be 0. And that's going to have a solid dot also, again, because we have a hard bracket here. 2 squared is 4. Now we'll go up to 2, 4, but that's going to be a hollow dot. We know that because of this open parenthesis here. X equals 2 is not really included on this graph. And then lastly, I'm going to pick a number between like 1. 1 squared is 1, so that's going to go here. And now I'm going to have this parabolic shape going through those 3 points. Okay, my scale wasn't perfect there. It could have been a little bit better. All right. Okay, and then lastly, this last section from 2 to 4. So I'm going to mark off, here's 2 on the x-axis, 3 and 4. Okay. And in this case, y is equal to x. That's the equation we're really graphing. So if we plug 2 into that, we'll get back a y value of 2. So we'll go up to 2, solid dot. If we plug 4 in there, we get a y value of 4. And we know it's a straight line, so we can just connect it. Okay? And when you're done, this picture you get is a picture of that piecewise function. So that's generally your plan. You look at each special domain, each little piece of the domain, graph the function that works for those x values, and when you're done, you end up with the total graph. Make sure you pay attention to like what's included, what's not included, and so forth. Let's quickly look at how to graph this. If you start with this first section of the piecewise function, when x is -3, we plug that in. 1 minus -3 gives you 4. You'd have a solid dot up here at the point -3, +4. Okay. All right? And then if we plug in -1, 1 minus -1 would give us 2. So we know we go through the point -1, 2. So, and that's a line segment. When you look at this, you know it's of the form mx plus b, or however you like to think of it. That's a line, so it has to be a straight line connecting those dots. 5, not a big deal, because it doesn't vary with x. So we just go from -1, we go up to 5, hollow dot on this side, over to +1, solid dot. I have to say, I looked over a lot of shoulders. The first two things looked good, almost all the papers. I was pretty happy about that. Actually, I should have color-coded that to be consistent. Let's make that one red, so we're careful. Okay, here's the part where it wasn't terrible, but I just had to correct a few people, and then there's a few others I didn't say anything to, but you should pay attention now, and you'll see what I'm talking about. If we look at this last function from 1 to 9, and we take 1 and we sub it in, the square root of 1 is just 1. We know it's not really included, so there's going to be a hollow dot there. And if we plug in 9, square root of 9 is 3, so out here we'd go to 9, 3, and we'd have a solid dot. Now the question is, how do you connect the stuff in between? Okay, so some of you know, right? There's some kind of curve. Let's draw in the air with your hands. Okay, so a lot of you know how to draw it. If you're ever in doubt about that, a couple things, like for example, if it's not a line, you might not be sure which way it's curving. There's lots of ways we'll learn how to deal with that. But for the time being, just pick some point somewhere else in the domain between 1 and 9. So I would pick something that's convenient. In this case, I would pick 4. 4 is a perfect square. Square root of 4 is 2. So that puts us up here. And what you'll notice is that's slightly higher than what it would be if we had a straight line between the points, which means it has to be curved sort of, we'll say downward for now. We'll come up with better language for that later on in the course. Okay. Now, the next question is, can you go backwards? So suppose I give you a formula for a piecewise function, right? Can you now write down a formula for that? Let's see what happens. So let's take a look at this one. A plan might be to go through, find the equation of each line, and then afterwards put it together in one piecewise function with the correct domain. Okay. I would say that's probably the easiest equation to find. So y equals 3. That one's good. All right, let's talk about this one here. Okay. So what do you think? What do we need to know? Yep. We need to know slope, and we need to know the y-intercept would be nice. We have it in this case. Y-intercept is 1. So we know our equation looks like y equals mx plus 1. And to get our slope, if you want, you could just look right on the graph, right? And if we look right on the graph, we'd have to go up 1 to the right 1. So that means we have a slope that's 1 over 1 or just 1. So this first equation is y equals x plus 1. We have the second one. Let's get the third one. Okay. Here we don't really have the luxury of the y-intercept. Some of you may decide, someone may look at this and say, I bet I can trace this back and figure out where it would hit the y-axis. I'm willing to bet. Show of hands, who did that way? Okay, fine. Who used point slope form of a line? Anyone use that? Okay, there we go. That's what I thought. So y minus y1 equals m times x minus x1. And we know 2 points it goes through right away. Here's 1, 3, 2. So I'll use that. Y minus 2 equals blank, x minus 3. And the only other thing we need is slope. But we can find that just by inspection, really. We went down 1 to the right 1. So my slope here, change in y over change in x, is just -1 over 1 or -1. So that's what goes in here. Okay. So we'll start to write our piecewise function and put this all together into one thing. So I'll call it f of x. So f of x equals, and a convention is normally you list them in the order of the domains that come first. And here's what I mean by that. This first line, y equals x plus 1, is as we're moving from left to right, we read the graph as the first one we see. That goes from -2 to +1. So I'll place that equation first. Notice how I don't write y equals. That's just I'm just teaching about notation here. We don't write that. And the x values that we're going to use this equation for are -2 inclusive up to +1 inclusive. And we know that because we have solid dots at the end of the lines. Okay. The next line is just 3. Notice, again, I don't write y equals 3. I just write 3. And we're going to use that equation from 1 to 3, non-inclusive. Okay. Lastly, for this last equation, just be a little bit careful. What you want to do is take this thing and rewrite it just as y equals. So I'm going to move that 2 over. You can leave it. -1 times x minus 3 plus 2. I am not bothering to simplify that. You can if you want. Okay, and we're going to use that for the domain from 3 to 6.